Hi, are you excited? We're finally going to look at a real mathematical geometry proof. Now, I have to preface this and say, if you are still in chapter 1, there are a couple ideas like perpendicular and whatnot that come out of chapter 2. So don't freak out that you don't understand it fully. I just kind of want you to see the flow of a proof. Okay, so as we said, the first thing you do is you look here, you'll have givens, so this is your starting point, remember, this is your Hoffman Estates High School. You'll have a proof statement, this is your Schaumburg Library. You'll have a diagram, which is kind of like your roadmap, and you have to fill in the two columns. Okay, so the first thing, where do we start? We start by looking at our givens. Okay, 100% of the time we take those 3 givens or 2 givens or however many are there and we put them into step 1 on the statement side. Every single thing, word for word, symbol for symbol goes right here. 100% of the time, the reason for step 1 is given. This is non-negotiable, nothing to think about. Step 1, I always say, is kind of a non-thinking step. So you jot it down, and then we're going to start marking up our diagrams. So the first given right here says that the measure of angle A is 30 degrees. So I'm going to mark that. Okay, the second given right here says that rays CB and rays CD are perpendicular. So I can go ahead and mark the right angle in there. Okay, third one says that angle BCE is 60 degrees. So I go ahead and mark that. So next, I'm going to actually ask you to look at your proof statement. Where are we trying to go with this? I want to prove angle A and angle ECD are congruent. So let's mark it and see what that looks like. Do you notice anything? Do you notice that the 2 that I marked in green, remember that's our end game. Okay, I can mark it here so you can see it. Do you notice that one of the ones that I want to prove congruent to the other one, I already have a number on it. I already know that this side is 30 degrees. So what is my goal? My goal then has to be to get the other one to be 30 degrees. I'm going to put it in green there. That is my goal, is to get this guy right here to be 30. If I can get that side to be 30, then I can say this one's 30, this one's 30, and they're equal. So I have to just figure out, well, how can I prove that that one's 30? Okay, so let's see if you can follow my thinking here. Here's what I see. I'm going to go back to this given and say, okay, what is perpendicular? Right? That's the first thing that I marked on that diagram. Well, that's perpendicular. Perpendicular leads me to a right angle. Okay, that's what our theorem says. If 2 segments are perpendicular, then they form a right angle. If 2 rays are perpendicular, then they form a right angle. Okay, why does the right angle help? The right angle helps because that gets me to 90 degrees. Maybe you're seeing it now. How does the 90 degrees help me? The 90 degrees helps me because if I know that this big angle here is 90, and I know this piece of it is 60, well, guess what 90 minus 60 is? Oh my gosh, I'm not getting better at writing, am I? 90 minus 60 is 30. Ding, 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 ding. That's my end game. That's where I wanted to go. Okay, so now we need to find a way to formally say all of that. But really, this right here, that's my proof. Here's my given statement that leads me to what I'm going to say in step 2. Okay, I'm going to make this jump. All right, so look at what I've written here. I'm saying that angle BCD is a right angle. How do I know that? Because if 2 rays are perpendicular, then they form a right angle. Now I am going to try to color code this for you. So try to follow what I've done here with the color. If 2 rays are perpendicular, why is that in black? Because I wrote it up here in black in the given. So if you take a look at this side, okay, the if has to come from something already established. The then should go directly across with what you're trying to actually say. So if 2 rays are perpendicular, and I knew from step 1 that they were, then they form a right angle. That's the rest of the theorem. So this right angle here matches this right angle here. Okay? Basically, we're saying because in a previous step, aka the given, step 1, because the rays are perpendicular, this led me to know that a right angle was formed. What right angle? Remember, this side's specific. What right angle? Angle BCD. Okay, so let's look where we're at with things. I got from perpendicular to a right angle. That was what I did in step 2. This is what I had in step 1. This is what I established in step 2. So what's the right angle lead me to? My chain logic here leads me to the fact that a right angle is 90 degrees. So what am I going to say here in step 3? Well, if an angle is a right angle, and I already established that it is previously. So if an angle is a right angle, then it measures 90 degrees. Okay, so again, look at what we've done. We said because in step 2 we knew it was a right angle, this led me in step 3 to say, well, now the angle measures 90 degrees. So step 1, this is given. Then I went to there. Now I'm here. Okay, remember this side is the claim. This is specific to the diagram. This is using letters. This is using numbers. Okay, over here, these are general statements that could go to any proof. So one more time, let me make sure you see the progression. Here in step 1, that was perpendicular. In step 2, there was the right angle. In step 3, that was the 90 degrees. So look here, 1, 2, 3. There's the progression. There's the progression. You can't skip over a step. Remember, these are roadmaps, step-by-step directions. You miss one step, we're lost. So I've done all of this. This is what I have left. Okay, look at what I've done now. Here's our new step. Now I can establish that angle ECD is 30 degrees. And how did I do that? Well, just like I did up there with subtraction. Now, formally, I have to say, this part should not be here. So if we go ahead and stick this in parentheses, that's you telling me, I know that this shouldn't be here. But my suggestion to you is to put it there because this is going to help make sure everything is the way it needs to be. Okay, here's how you're going to read this. The left side have to be numbers that are previously established in other steps. So I can look at the 90 and say, where's the 90? Oh, here's the 90. Okay, yes, that one's established. That's a check mark. Okay, 60. Well, where's the 60? Oh, here's a 60. Okay, that's previously established. So if you can't find these two numbers somewhere up above the current step that you're on, then you're not ready to say subtraction. The right side, okay, when I see this 30 on the right side, that should match straight across and be your current step. So my suggestion is to have the numbers here because I think they will help make sure you're not skipping steps. Okay, so now look what we've just done. We have just said that ECD is 30 degrees. So in my proof, I can now find both 30s. Measure of angle A is 30, measure of angle ECD is 30. Now we're ready to go ahead and say they're congruent. I can't stop until I actually, in a proof, you always have to end with your proof statement. Okay, look at, we've wrapped it up. My proof ends when I'm able to write that proof statement. And I did. I had my whole progression. Here was step 1, led me to this in step 2, led me to this in step 3, led me to this in step 4, and then here's step 5. So quickly before I sign off here, make sure you see the if has to match a previous step. This is my if here, previous steps. Okay, my if here goes to previous steps. The then matches directly across. Super important for proofs.